Okay guys, so we are dividing decimals by decimals, and we're going to do it with a really simple equivalent fraction tool, or strategy I should say. And the most important thing is not actually, you're not introducing anything new in terms of their basic division, but that they have to keep very careful track of their work. That's going to be the main thing. So before we solve 2 divided by 1/10, let's think about how we can use what we already know to get the answer. And I let kids just think about this. I think they would really surprise us with what they come up with, right? If I'm dividing 2 by 1/10, I might think about 1 divided by 1/10 and then double it, right? I might think, okay, I have 2 wholes and I want to see how many tenths are inside, right? Or I might try to do this 2 divided by 1/10. I might think of it as 1/10 times what makes 2, right? And as I do this work, one of the things that I see is that I'm going to get a great big number, right? I'm going to get a lot of tenths inside of 2. Or if I want my tenths to get multiplied to make 2, I'm going to need a lot of those tenths, right? I'm going to need 20 of those tenths to make the 2. And so when I do this work, right, it's almost like thinking of, again, like keeping the tenths in mind. And the scale is really, really important. And now it doesn't just affect this number, it really affects how many times it would fit in this number, right? Like the tenth is relevant for both of these sections. And so today, we're actually going to turn our work into a fraction. And when we go ahead and change it so we can just think of it as whole numbers, we're going to notice, right, that the numerator and the denominator kind of have to change together to make it something that we can understand, right? Like that's kind of the point of this as an exploration. And so once they've kind of solicited their ideas and you're really thinking like, wow, when we divide by a decimal, we get something really big, right? We don't actually get something smaller. Then we're going to just do the work, right? And so we're going to use equivalent fractions to change our divisor into a whole number following these steps. And you're just going to use the one that was there, right? 2 divided by 0.1. Then, if we have tenths, we'll multiply by 10 over 10 to get rid of that denominator, or 100 by 100. And then we can just divide by like normal, right? So it'll look like this in this case. Remember, that shifts that decimal, those numbers over, so we end up with 20 divided by 1. And now we divide like normal. It's really easy to get our answer. Let's try another example. Right? 2 divided by 0.2. Oops. We're going to multiply by 10 over 10. We get 20 over 2, because remember, that shifts the decimal. That equals 10. And if we want to go back to what we talked about in the first place, to check this one, 0.2 times 10 equaling 2, that actually works. It shifts the decimal over. It's true, right? Let's do this one, 2.4 divided by 0.2. We want to get rid of the tenths, so we do times 10 over times 10. We have to do the same thing on both. We get 24 divided by 2, that's 12. Now this one's a really interesting case, because I could decide I have hundredths to multiply by 100. If I decide to multiply by 100, it's actually not wrong. I get 248 divided by 20, right? And again, think of it as shifting the place values over, which moves that decimal point. If I decide to do it just by 10 over 10, that's fine too. I get 200, oops, it was 2.48, I'm sorry. I get 24.8 divided by 2. As long as I don't have a decimal in the denominator, I'm going to be fine, right? Here, I do this work. I get, well, this one's a little bit tricky because I end up with a remainder. So that's actually a little bit tough, right? Because I end up, let's say I divide by 200. That's 10. I divide by, how did that even work? I'm really struggling here, guys. Sorry, 40. I end up with this remainder 8. It's really hard to divide. I get 12, remainder 8. So then I'd have to add a 0, and they're not ready for that yet. It can be done, but we're going to end up getting a remainder, and we don't know how to deal with that till the next day. So we're not going to make it bigger than we have to make it. We just stick with this one, 248 divided by 2. Right, we get our answer. We get our answer, 100 and whatever it is, 124. But it's 124 tenths, right? Remember, these were tenths. And so we are going to put our answer in the tenths place. Now, let's go back for a second because I had to pause even. My brain was getting stuttered around this for a second. I'm going to change my color for just a minute here. This, putting it back as tenths, this is the first time it's happening. Right here, when we multiplied 10 over 10, we had 2 whole numbers. Here, we ended up with whole numbers. But here, we multiplied by 10 over 10, we didn't have whole numbers. So we had to go back to what we had learned the day before, right? Which is divide 24.8 by 2, like it's 248 by 2, but then remember, it's tenths. We have to go back and put in the tenths, right? And even like keeping that decimal as you're dividing, right? But then do it and put the decimal back in. So that is going to be the most critical part. Otherwise, I think this is fairly review, right? What do you notice about the decimal point and the digits when we use tenths? So this is really interesting, right? Like, I'll just go back to my normal thing, right? When I do 2.48 over 2, and I multiply it by 10 over 10, right? I have to shift my digits over. I have to shift my digits over. What am I noticing happens to the decimal point? The decimal, right, goes one shift to the right for the top and the bottom, right? It goes boop, boop, which is probably how you learned it in middle school if you learned how I did, or in middle school I actually learned to set it up like this, and then whatever I shifted this by, I shifted this by. That's not like wrong, but let's remember why we're doing that. That's the same as multiplying this by 10 over 10. And we haven't taught it as a shift in the decimal. We've taught it as a shift. I'm going to start like this. In the digits, right? The digits go like that. So just keeping that in mind, right? Here, we're going to notice that the decimal shifts to the right. I'm sorry, the digit shifts to the left, right? We're going to notice the decimal shifts to the right, and that's helpful noticing to kind of show how we get this final answer. But you also want to come back to, like, why did that work, right? What was really happening? And what was really happening was that the digits shifted to the left, right? The decimal shift looks like it's shifting to the right because the digits shift left. And even why did the digits shift left? Well, because each place value is 10 times the place to the right. So when I say 10 times, I just have to move to the next place, and that's 10 times. So that's your biggest, like, if I have to flag for you, it's like the why of this is really challenging, and then remembering to pay attention to the place value if it's left, in that last example we just did. After that, it's just guided practice, and they should be this is fairly procedural, right? But what's cool is at the end here, you have another opportunity to ask the question a different way. What did you notice about the decimal point when we use hundredths stringing? And so you can have the same conversation this time. In order to do this, the decimal would have shifted 2 places. Why? The digit shifted 2 places, right? So you're going to get something like 12.89. If I have this, I'm going to multiply times 100 over 100. It's going to look as if my decimal moved 2 spots over. Why? Because my digits really on a place value chart moved 2 spots over. So that is a big idea there.